Hello friends, today we are starting with our topic that is trigonometry, and in our first lecture we are defining that what is trigonometry. Trigonometry is trigonometry, means three sides measurement. Suppose we have a triangle which is a right angle triangle and ABC is our triangle, right? And this is a base. This is angle theta, or you can say we can take this as an angle A, there is no issue. And the opposite side with respect to the angle A is called perpendicular. And this is our hypotenuse. Hypotenuse is the longest side, right? Hypotenuse is the longest side of the triangle ABC. Whenever we calculate the sine of this angle, sine of angle A, then sine of angle A is defined as BC upon AC. BC means the side which is opposite to the given angle A upon this hypotenuse, right? So we can say it is perpendicular upon hypotenuse. In short, we can take P upon H, and cosine of A, right? Cosine of A, that is taking as AB upon AC. AB upon AC means that is base upon hypotenuse. In similar way, we can find out the value of tangent of angle A, that is perpendicular upon base. Perpendicular upon base means that is BC upon AB, that is perpendicular upon base. Sine of A is nothing but it is treating as sine of A in this way, that is P upon H, or we can write it as cos of A, that is B upon H, and this is tangent of A, that is P upon B. And cosec of A is the reciprocal of sine of A. So cosec of A can be treated as H upon P. Similarly, the opposite of cosine, that is secant of A, that is H upon B. And third one is cotangent. Cotangent means cot of A is equals to B upon P. So these are the formulas which are associated with the ratio of the sides of this right angle triangle, right? So we are taking base as AB, perpendicular as BC, and hypotenuse as AC, and we can note that here sine of A, cos of A, tan of A, and their reciprocals are representing in the form of the ratio of their sides. So these are called trigonometric ratios. These all are called trigonometric ratios, right? And whenever we have any two of the sides in our question, when you will perform any question and we have these two sides, then how we can find the third side? We can use the Pythagoras theorem. By using Pythagoras theorem, we can evaluate the value of the third side, right? And what is the Pythagoras theorem? That is hypotenuse square is equals to perpendicular square plus base square. So by using this, that is Pythagoras theorem. Pythagoras theorem. With the help of Pythagoras theorem, we can find out the third side whenever we have two sides of the given triangle. And obviously, the trigonometry is applicable on this right angle triangle, and we are discussing about only acute angles. In today's lecture, we are discussing about the measure of the acute angles only. Here A is the acute angle, its measure is less than 90 degree, right? So we can define these all terms as a trigonometric ratios with respect to the given right angle triangle. How would you perform the questions which are based on these kind of formulas? Suppose we have this question, given that cot of A is 8 upon 15, calculate other T ratios. T ratios means that is trigonometric ratios. How we can find out the values of trigonometric ratios? So here we are performing this question. Suppose cot A is given. Cot A is 8 upon 15. Now we will draw a right angle triangle. This is ABC, right angle triangle. And here the measure of this angle is given by cotangent. That is cot of A is equals to 8 by 15. And we know that what is the formula for cot A? That is reciprocal of the tangent, and that is base upon perpendicular. Right? Base upon perpendicular. What is our base? Base is AB, and what is perpendicular? That is BC. And here the value of base is 8 and 15. It is given that cot of A is equals to 8 by 15. So we can say the cot of A is 8 upon 15. Means AB is equals to 8 and this BC is equals to 15. In some of the books, it is referred that 8 upon 15 doesn't mean that the length of the sides are 8 and 15. So in our questions, we can replace it by 8K and 15K, because 8 by 15 indicates that the ratio of their sides is 8 is to 15. So sometimes the people can take the measure of AB is equals to 8K and BC is equals to 15K. That is also correct. Otherwise, we can take in simple manner, that is AB is equals to 8 and BC is equals to 15. There is no issue for that. You can take 8K or 15K at the place of AB and BC, or you can take 8 or 15 simply, right? So when we are taking this is 8 and this is 15, then we can use Pythagoras theorem, that is AC square is equals to AB square plus BC square. Then what is the value of AB? That is 8. And what is BC? That is 15. Then this is equals to 8 square, that is 64, and that is 225. So we get 9, and that is 8, 217. And 217 is AC square, 289, that is AC square. Then AC becomes 17. Yes, the 17 square is 289. Then we can find out the square root of this. That would be 17. And after calculating this value, now we know the measure of this hypotenuse. And if you know the measure of hypotenuse, then we can calculate all the 6 trigonometric ratios, right? So all the 6 trigonometric ratios means we have the formula for sine A, that is P upon H. P upon H, what is P? That is 15 upon H is 17. So we have 15 upon 17. What is the measure of cos A? That is base upon hypotenuse. So base upon hypotenuse, that becomes 8 upon 17. And here we have tangent of A. What is the value of tangent A? Perpendicular upon this, that is 15 upon 8. And we know cot A, that is 8 upon 15. And what is secant A? It is a reciprocal of cos A, that is 17 upon 8. And cosec of A is a reciprocal of sine, that is 17 upon 15. In this way, we can calculate all the trigonometric ratios, which we have already told in our previous slide. Now, we can calculate if any of the T ratio is given, like cot A is there, then we can evaluate all the 6 trigonometric ratios. If you have any other like sine, cos, so do it in the same way as I have discussed in this question. And second one is sometimes question is there, and how you can find out the value of cos of C, how you can find out the value of secant of A. So we can use this angle as the basic angle or this angle as the basic angle. So both concepts are different, right? So we are taking some one more example to understand the concept. If angle A major or angle C major both are given, then how we can solve that kind of problem, right? Now our second problem is in triangle ABC, the tangent of A is equals to 1 upon root 3, and obviously the angle B is 90 degree, and here we are constructing the triangle, that is ABC, and this tangent of A is 1 upon root 3. Then find the value of sine A cos C plus cos A sine C. So here we have two kind of measures, angle A major and angle C major. So first of all, we are taking the conditions with respect to angle A, and we are defining the values of sine A and cos A. How we can find out their values? So first of all, if tangent A is there, what is the formula for tangent? That is P upon B, that is perpendicular upon base. So perpendicular is BC, so BC is equals to 1 and AB is equals to root 3. When you take this is 1, this is root 3, then we can find out the value of hypotenuse by using Pythagoras theorem. That is AC square is equals to AB square plus BC square. That is Pythagoras theorem, right? So after using this Pythagoras theorem, we have AC square is equals to 1 square plus root 3 square, that is 1 plus 3, that becomes 4. So AC is equals to 2. So we can find out its value, that is 2. And after finding out this value, now find out the value sine A. What is sine A? Sine A becomes perpendicular upon hypotenuse. What is perpendicular? 1. Hypotenuse is 2. And similarly, we can find out the value of cos of A. That is base upon hypotenuse. Base is root 3 and hypotenuse is 2. So its value becomes root 3 upon 2. In same way, when we will take C as the measure, if you are taking C as the measure, then this becomes base, because this angle, this measure is with respect to this base. So we are taking BC as the base for the angle C. You should write it. For the angle C, the base is BC, that is 1. And what is the perpendicular? That is AB. Perpendicular is AB, that is root 3. And with respect to C, this is our hypotenuse, that is 2. Hypotenuse is same for both the cases, that is 2. And now you should calculate the value of cos C. What is cos C? That is cos C is equals to base upon hypotenuse. So base is here BC, right? With respect to C, the base is BC. So we should have base upon hypotenuse, that is cos C, that is BC upon AC, that becomes 1 upon 2. And what is the value of sine C here? So sine C is opposite side of C, that is AB. AB upon perpendicular upon hypotenuse, that is root 3 upon 2. In this way, we can find out the value of sine C. And what is our question? We need what thing? That is sine A cos C plus cos A sin C. What is the value of this expression? Then sin A is 1 upon 2. And what is cos C? That is 1 upon 2. What is cos A? That is root 3 upon 2. And what is sin C? That is root 3 upon 2. In this way, that is 1 upon 4. That is 3 upon 4. That becomes 1. So its value becomes sin A cos C plus cos A sin C becomes 1. This is our final answer. It is the value of this expression. So in this way, if you need the values, the measure of T ratios of angle A and T ratios of angle C, so we can find out simply by taking angle A and take base this and perpendicular this. And when you are taking this measure, angle C measure, then base will be BC and perpendicular is AB. And hypotenuse is same in both the cases. Again, apply that theorem, Pythagoras theorem, and evaluate the third one, and then calculate the T ratios with respect to both the angles and substitute their values sin A cos C plus cos A sin C. Trigonometric ratios of some specific angles, like we know the value of sin 45 is 1 upon root 2, and value of sin 60 is root 3 upon 2, and cos of 30 is root 3 upon 2. But how we can obtain these values? And we have to understand this concept by using this lecture. And here we are taking, suppose we need the value of sine of 30 degree. How we can find out the sine of 30 degree? Suppose we have a triangle. This is an equilateral triangle, right? ABC is an equilateral triangle, and draw a perpendicular from here, and this is of angle 90 degree, and we are treating these sides as 2a. Each side is equals to 2a, right? We are taking each side of this triangle as 2a because it is an equilateral triangle, so all the sides of the triangle are equal. And obviously this angle is of 60 degree in an equilateral triangle, and this would be 30 degree, right? So when we are taking this triangle ABD from triangle ABD, we are interested to calculate the value of AD first. What is the value of AD? If we know the hypotenuse, that is 2a, and this is our base, that is a, how we can find out the value of perpendicular? We have to use the Pythagoras theorem, right? So when you use Pythagoras theorem, the AD square becomes AB square minus BD square. What is AB square? That is 2a whole square minus BD square is a square. That is 4a square minus a square, that is 3a square. In this way, the value of AD becomes root 3a. That is our ratio for side AD, that is root 3a. Now, what is the value of sine 30? We are taking, what is the value of sine 30? So sine 30, if we are taking this as an angle, then this will be the base. So AD becomes base and BD will be the perpendicular, because this opposite to this angle we have the perpendicular. So this is equal to perpendicular upon hypotenuse, that is BD upon AB. This is the perpendicular with respect to 30, and this is our hypotenuse for the triangle ABD. And now that is BD is A and AB is equals to that is 2A. That becomes 1 upon 2. In this way, we can evaluate the value of sine 30 degree. It's okay, fine. There is no problem to calculate this value. Similarly, from the given triangle, we can obtain the value of sine 60 also. What is the value of sine 60? We can see from this triangle again, for 60 degree, we have this as the perpendicular. This AD is the perpendicular and BD is the base and AB is the hypotenuse with respect to 60, right? So 60, in front of 60 we have AD. Then what is the formula for that? AD upon AB. What is AD? AD is root 3a. That is, we have calculated from this, AD is root 3a. So root 3a upon 2a. That becomes root 3 upon 2. Then sine of 60 becomes root 3 upon 2. In similar way, from the same expression, same triangle, we can obtain the value of cos 30 and cos 60 also, right? So cos 30 becomes sine, that is cos of 30. What is the formula for cos 30? Cos 30 is, we have to take this as a base, that is AD upon AB. AD upon AB. Then what is AD? AD is root 3a and that is 2. That is again root 3 upon 2. So cos 30 becomes root 3 upon 2. In similar way, we can find out the value of sine, that is cos 60 also. What is the value of cos 60? Again, with respect to 60, we have base BD. So BD upon AB. In this way, we can find out the value A upon 2A, that is 1 upon 2. Then cos 60 is equals to 1 upon 2. So here we can say, we can check that. What is the value of sine 30? That is 1 upon 2. What is the value of cos 60? That is 1 upon 2. It means we can say sine 30 is equals to cos 60. In similar way, what is the value of sine 60? Root 3 upon 2, and value of cos 30 is root 3 upon 2. Means these two values are also same, because cosine is called complementary of the sine, right? Cosine is called complementary of the sine. So if the angle, the sum of these two angles is 90 degree, then these two measures are same, right? So cosine of the angle means complementary of the sine. So 30 plus 90 becomes 30 plus 60 becomes 90. So sine 60 is equal to cos 30 and sine 30 is equals to cos of 60. So we can check by using this article. Similarly, if you want to calculate the value of sine 45, sine 45 is 1 upon root 2 and cos 45 is also 1 upon root 2. We know about it. So we can calculate their values also, because whenever you read the table in the 10th class, so when you calculate the values like sine 40, what is the value of sine 45, sine 30, sine 60? So we know we can cram all these values, but we don't know how we can calculate those values. So you can calculate by using this kind of triangle. And I am taking one more thing, like how you can define the value of sine 45 degree, cos 45 degree, tangent 45 degree. Now from here we can calculate the value of tangent 30 also. How we can define tan 30? Tan 30 becomes sine 30 upon cos 30. When you divide sine 30 by cos 30, we can find out the value of tangent 30, because we have the formula tangent of theta is equal to sine theta upon cos theta, right? And cosec is the reciprocal of sine, secant is the reciprocal of cos. In this way, we can calculate all the t ratios with respect to the given angles like 30 and 60 degree. Now we are defining the value of sine 45. Yes, now sine 45, how we can find out the sine 45, right? For sine 45, we are taking again a right angle triangle. This angle is of 45, then obviously this will be 45. And if two angles are same, then this is an isosceles triangle, right? This is an isosceles triangle. So isosceles triangle, in triangle ABC, we have AB is equals to BC. Both are same. So we are taking this as 1 and this is also 1. Now, what is the value of AC? AC square is equals to AB square plus BC square, 1 square plus 1 square, that is 2, and AC is equals to root 2. AC is equal to root 2. So AC becomes root 2, and now we can calculate sine 45. What is the formula for sine? That is perpendicular upon hypotenuse. So that is BC upon AC, that becomes 1 upon root 2. In similar way, we can find out cos 45. What is cos 45? Base upon this, that is AB upon AC, that is 1 upon root 2. It means sine 45 is equals to cos 45, that is equals to 1 upon root 2. So obviously we know the values of sine 45 and cos 45, these are 1 upon root 2. Whenever you divide both the values, like sine 45 dividing by cos of 45, we obtain the value of tangent 45 also, that is sine 45 upon cos 45, that becomes 1. So tangent 45 will be 1. So in this way, we can find out the values of t ratios with respect to the acute angles like 30 degree and 60 degree and 45 degree. And one more interesting thing is how you can find out the value of sine 0. Sine 0 is 0. We know sine 0 is 0. How? Sine of 90 is 1. How? How we can obtain sine of 0 degree? That is 0. And what is cos 0? That becomes 1. Right? So suppose we are taking this triangle. Just imagine this is ABC and this is our angle A, and this is the same triangle I am taking. This is also similar in size, and I am taking this one more triangle, same in size, ABC, because I want to realize the result step by step. Suppose we have this thing, right? So suppose sine A. What is the formula for sine A? We know what is the formula for sine A. That is BC upon AC. That is perpendicular with respect to A, and this is hypotenuse. So perpendicular upon hypotenuse is our formula. If, and what is cos A? Cos A, yes. What is cos A? Cos A is AB upon AC, right? So for this triangle, we have these two results. Now we are going in this way. I am taking this as the previous triangle and decreasing the size of BC. Now this is our new BC, right? So BC will decrease and then hypotenuse will also decrease. Means I am taking this hypotenuse approaching towards this base, right? Hypotenuse AC is approaching near to AB, because when this angle becomes 0 degree, when angle A will approaching towards 0, means this its value becomes 0, then this AC becomes at this place. So angle A becomes 0 and C point will coincide with the B point, right? So this angle becomes 0 degree, right? So when this angle is 0 degree, AC becomes AB, then sine of 0 becomes AC becomes AB, so cos of 0 becomes AB upon AB. That would be 1. There is no issue. Cos of 0 becomes 1. But how we can find out the value of sine 0? So again, we have to see that this BC becomes 0, right? When this AC becomes AB, then where is BC? So B will approaches to B point is approaching to C, means this value becomes 0. So if BC becomes 0, then this is 0 upon AC, that will be 0. Right? So there is a simple concept. Whenever this AC hypotenuse will approaching towards AB, what will happen? This angle becomes 0 and this AB side becomes equals to AC and BC got diminished and approaching to 0. By virtue of which we can obtain sine of 0 becomes 0 and cos of 0 becomes 1. So in this way, we can show that the value of sine 0 is 0 and cos 0 becomes 1. And how we can show that the value of sine 90 and cos 90. That is, again, it is an approaching case. We can see the NCRT books or any other books. You can refer these books and obtain the value of sine 90 and cos 90 also. Right? So we are ending our topic at this place. Meet you soon in our next video. Thank you.